vectors with a sum that is a vector R. So basically, when you have two or more and you put one or the other, this is then my component vector. Is R. Is when we put X is one vector, and then we add Y, gives us the component vector. It's from starting initial to one to the final of the other. Da-da-da-da. So basically, we're going to be using component vectors in order to find the missing information.
Wait, with the sum T8? Oh,
With number 3.
Is that a really spaced out this?
yeah.
What?
After the word
Sum?
sum, is that this really spaced out? Or
Oh,
This
with
is-
a sum.
Which one?
That is.
That is?
That.
Okay.
Sometimes my brain gets ahead of my. Sometimes my writing gets ahead of my brain.
No, I read it as that though. I just, yeah, I
Wondering,
read it
sure.
as that.
Oh, your hotel did. You want
Because
it?
we can go like. Okay, so number
But you're
3.
way better at math than I.
Point number 3. While digging in his garden, Will pushes a shovel into the ground with a force of 630 newtons at the angle of 70 degrees with the ground. So here is our
Wait.
ground.
You say meters?
What?
What? Newtons.
Never mind. Never mind.
So here is the ground. That's grass. Guys, can you stop talking?
We're talking about that.
No, you're not. We can always record the video. We can always replay the video because I'm sure it picked up your whole conversation. So, here is the ground. So according to the ground, Will pushes a shovel at how many degrees?
70.
70 degrees at 630 newtons. Right? So this right here is my component vector. So what it wants to do is want you to find the magnitude of the horizontal and vertical components of the force. So this gives me R, and the question wants me to find X and Y. That was one of you.
It's like we're done with the
Yay.
Questions on how I drew that picture?
You get to use trig.
Right,
Yeah.
so we have, just like in geometry, there's 3 options. We can use SOHCAHTOA, we could use law of sines, or law of cosines. Which would be the ideal to solve for this?
SOHCAHTOA,
Oh.
Why?
because the easiest.
No.
Because we have an acronym for it.
No.
Oh, you mean this particular problem?
Why are we using SOHCAHTOA and we cannot, and we shouldn't use law of sines or law of cosines?
Because it gives you the numbers.
Because we have an angle on the side.
Because this is a complete, is it horizontal, right? Horizontal.
No,
No,
it's
horizontal.
Vertical and
Yes.
horizontal. So it's straight.
Also,
as
it's
a right
90
angle.
degrees.
This is a right and 90 degrees. Every time you see 90 degrees, you automatically default to SOHCAHTOA. If it's not 90 degrees, you have to either use the law of sines or the law of cosines. Does that make sense? So automatically you see right angle, you're going to stick with. Now, which one am I going to use for which? If I'm solving for y, let's start with y.
Cosine.
So according to y, what is r?
Hypotenuse.
The hypotenuse. And 70 is my
Angle,
angle. So
cosine. Because y is the opposite.
because y
I
is
meant-
the
I meant,
opposite, so I have to use
so
sine,
sine. Yeah,
right?
that's what I said.
Sine of 70 equals 630 newtons over, no,
No, it should be,
y over 630 newtons. Are there any questions on how I did that? Any questions on how I set that up?
No.
Basic geometry, yes? So then, in order for me to solve, what do I need to do? What?
Multiply both sides by 630.
Right, I could either cross multiply, or I could, if this was missing down here, I'd cross multiply, but because this is not missing, I'll just do 630. 630. What is this?
592. Is that what you guys got? Is that what it is?
hold on.
I got nowhere near that. Just kidding.
It's,
What the? I don't even have a calculator.
what's the answer?
I got 592.
592,
Yeah. 0.006.
592
Oh,
B.
my bad.
This is my vertical. What's my setup for horizontal?
I'm gonna use
I still need
cosine.
to use sine of 70.
Oh, why?
I mean, I still need to use 70, sorry. Right?
Mhm.
So according to 70,
Only give
x
me-
is what?
Adjacent.
And the hypotenuse is still the hypotenuse. So I'm going to be using cosine of
70.
70 equals adjacent, which is x, over hypotenuse, which is,
630.
and then I multiply, same thing on both sides. What do I end up with?
You said 213
213 what?
newtons. Is that right? I heard somebody
I
say.
got 215.
215. This is horizontal. And then they told you the magnitude or the direction of the vector, and you were able to find its components, or they gave you the components and you were able to find the vector. Now, this is telling you if you can put the distance in a coordinate plane, that's your xy plane, then you should be able to find the magnitude of a vector. So the magnitude looks like this. It looks like the absolute value of the bolded letter. That indicates that it's the magnitude. And this looks familiar from geometry. What is this called?
Pythagorean theorem, but with like coordinates.
Huh?
Point slope form.
What?
The distance formula.
Oh!
It's the distance between 2 points.
We knew
Your
that.
initial point and your, what is this called?
Terminal point.
Terminal point. So basically this is the distance formula, but sometimes they won't give it to you in points. They give it to you in the component A and component B, and if that's the case, then you just take A squared and add it to B squared, and then you square root it. So either of these would work. It just matters on what information they give you, and that's to find the what?
Magnitude.
Magnitude, right? Which is basically the distance.
Which is still a derivative of the Pythagorean theorem.
No. Questions?
Wrong. Yeah.
Shut you
What'd you
down
just say?
twice.
Okay, vector operations is basically, you've dealt with it when we're dealing with matrices. And it's basically how you add, subtract, and k is called a scalar. It's just a value that you multiply to each one. So this is just editing the vector components, which is pretty self-explanatory. So number one, they're asking for the magnitude of AB with initial point A and terminal point B. So this one should be a piece of cake. you just label this one what? And this one,
Oh,
X.
X2.
Y1.
Oh, yeah.
and this?
X2.
Okay, and then we plug it into here. So equals the square root of 1 minus 1 plus, squared, plus 3 minus negative 3 squared, which is square root of 0 plus 6
Oh,
squared,
yes. Squared. 36.
which is square root of 36, which is
6.
6.
Wait, what is that? Is it absolute value of the vector?
No, that is how you, that's the sign for vector.
Oh, okay,
Yeah.
okay.
Miss P, how is this not Pythagorean theorem?
It's not the Pythagorean, it's the distance one.
Except for that.
Right. So if I were to put this on a plane, on a coordinate plane, that means I would move the vector that is 6 and I put it here as the initial point with a magnitude of 6. So that means in component form, this would be 0, comma 6. So this is the magnitude, and this is the component form. Be very careful on what they're asking you, because they'll ask you for both. Questions? Okay. The next one, we're going to do 2W and Y. So these are components, so they should be bold. And this should be bold, and this should be bold. I was going to put the little circly things, but I freaked you guys out last time.
The what things?
When I did this.
Oh, yeah.
Oh, the bold.
No.
What is
It
that?
looks like a
It's supposed to be
word.
bold.
That's not bold.
See, it freaked you guys out.
It's more like a, it looks like.
What is she doing?
Okay. So then we have to do, according to order of operation, listen, according to order of operation, multiplication comes first. So first we need to find 2W, which is equals 2 times 2, comma 2 times negative 5. So this is 4, comma negative 10. And then we do plus y, which is 2, comma 0, which then is 4 plus 2, comma negative 10 plus 0, which then is 6, comma negative 10. We're just adding and multiplying. Yes? It's just a matter of what order you're going to do. So we couldn't do W plus Y first. We have to do order of operations, so multiplication first. Yes? Are there any questions on this?
So you just plug in the numbers, pretty much?
The components, yes. So if it's a number in front of it, we do scalar, so we just multiply it to each one, right? If we're adding it or subtracting it, we take it, we take the first terms and add them together, or subtract and take the second terms. So then it ends up with this. So what this is telling me, visually is that W is 2, comma negative 5. So it goes
Oh, the
2
two numbers.
this way,
Alright, I get it now.
and then negative 5 this way. This is W, right? And Y is 2, comma 0. So 2 this way, 0. Oh, it's right up here. Yeah. So then what this is asking me is 2 W's plus 1 Y gives me negative 6, negative 10. So it gives me the exact location. So it goes negative 6,
Positive 6.
Positive 6, sorry. Negative 10. So the vector here would be 2w's plus y, if I took all of the arrows and put them together. So that's basically what this is asking. So it's asking, right? Here are your two vectors, w and y. It's asking you what position are you going to be in if you had 2w's plus 1y. And you would be at the component 6, negative 10.
But how did you get 10?
2 times negative 5. Because first I did 2w, right? 2w, so I did 2 times 2 times 2, and then 2 times negative 5.
Right.
And then once I got that answer, then I just added it y, because I just add 1y. Okay, try B. See if you get B right. Try B.
What about B?
She doesn't think it's funny. So
What'd
let's
What'd you get?
What'd
you
get?
get?
Guys, so then we have to do 3y.
Oh yeah, minus 2.
I'm sorry.
So
Can you go
3y
It's okay. Just finish it.
3 times 2, comma 3 times
She's like,
0,
I really need more super chips.
which
I'm like,
is
okay.
6,
6, comma 0. And then 2,
No Stussy?
guys, stop talking. And then 2z equals 2 times negative 1, comma 2 times 4.
I thought it's minus 2.
You can do minus 2, but then you have to add them at the end. So you can only apply the negative ones. That's a good question.
So positive?
So I do the positive, but if you do minus 2, then you have to add the answers at the end.
Alright.
So it's either or. So then from here it's negative 2, comma 8. So then 3y minus 2z is 6 minus negative 2. And, no, is it? Yeah.
Yeah.
6 minus negative 2 and 8 minus 0, which is 8, comma 8.
Negative 8.
It's 0 minus 8.
Oh, 0 minus 8, sorry. Yeah?
Yeah.
Questions on this?
Let me see.
What is?
It's recording!
Which stuff?
Hey, you haven't started yet.
It's recording!
Oh shoot.
Dude, you can use my fine iPhone app later.
For editing purposes, this is 8 to
B.
B. This is only the second lecture we've had, yeah?
Yeah.
Second half of the second.
They're flirting, somebody's done.
No.
Turn the camera.
We're using a calculator.
That's not the calculator.
You sound like such a liar. That wasn't even a good lie.
You know I always do that.
Alright, here we go. So, number 3, again, all of these things that we're doing are just ways to manipulate the unit vector so that you can get it, so you can interpret it the way you want, like data, right? Mean, median, and mode. They're all organizing or interpreting the same set of information. So a unit vector is same thing as finding the unit of a value, right? When you want to relate one vector to another vector, you're going to want to know how much, because this one is for every 4, you go down 2, right? So it's asking you what would your value be for, what would the magnitude be for one distance, for 1, 1. Does that make sense?
No.
Probably doesn't. So if you had something on sale and at the store and it's 3 apples for $1.50. Well, then if you don't want to buy 3 apples, you have to find the unit price, which is how much is then for 1 apple.
If they're all the same, then it'd be 50 cents.
Or if there's a sale.
Right, but I'm not telling you about answering the problem. I'm telling you, do you understand the whole concept of unit?
Yes.
Right? So for one, you want to know the cost of 1 apple so that you can buy it as a unit as opposed to buying all 3. So this is how we find it, right? We take the vector component and put it over its magnitude, okay? Now a unit vector, your answer is in vector mode, so you'll have so it'll look like this. Please remember the difference. Magnitude is one number, direction is one number, but a component vector, a vector, looks like this, two values with a comma and your vector signs, yes? So it's important to know because then you'll have to know what your answer needs to look like, okay? All right, so in this one we want to find a unit vector u with the same direction as the magnitude of the vector component 4 and -2. So in this case right here, we're going to be doing 1 over the magnitude of v for -2. So this is going to be our scalar, right? But we have to first find what the scalar is. So I'm going to take 4 and 2 and find the magnitude. That's from from yesterday's lecture. How do I find the magnitude?
Are we plugging them into that formula thing? The square root? Okay.
The square root of 4 squared plus
-2 squared.
-2 squared. So this is square root of 16 plus 4, which is the square root of
20.
20. And I think if this is not a whole number, they just leave it as square root of 20. Okay? And then, so my scalar is 1 over square root of 20, and I take it and I give it each component. So 4 over root 20, comma, -2 over root 20. And I think root 20 can be reduced to 2 root 5, right? So this is 2 root 5, and then 2 root 5. So then I can reduce, this is 2 over root 5, and then -1 over root 5. So this is my unit vector. Questions? Is our magnitude. So we go 60 degrees at magnitude 7. So what they want to find is component A and component B that make up that vector. Does that make sense? That's where this linear combination comes from. Is it this one? Where? What question
The
mark?
scalar thing?
No, that's 20.
This?
Oh, it looks like a question mark 0.
So these are our magnitudes. So in order to find the component form, we just plug it into the equation, like Tanner said. This is, so our magnitude is 7 cos of A, no, cos of 60, and then 7 sine of 60. Again, don't just take my word for it, or don't take the book's word for it. Figure out how they came up with this equation. If we're looking for this side right here, this would be, we're dealing with this angle, so this would be opposite over hypotenuse. So that's why they use sine, right? In this one, we'll be using the opposite angles here. That would be, well, hold on. Yes, so if we're using this, it's this angle every time, right? So in order to get this side would be opposite over hypotenuse, to get this side would be adjacent over hypotenuse, hence the sine and cosine. Yes? And it's always right angles. So we plug it in, the magnitude, 7 cos of 60 is
Wait, is that angle 60 or 160?
Yeah, 3.5.
right here.
Do you not like trig?
Me?
Yeah.
Do I not like trig?
Yeah, cause you like every time we do trig, you're like, ha. it's trig. You're like statistically.
UK 10.
Oh no, it's because we spent 2 chapters in a row on trig.
Oh.
So I thought I was just torturing you more. That will also be cut out. Sorry, 7 cos of 60 is what?
Yeah, 3.5.
And then 7 sine of 60?
6.06.
Yeah, me too. I have like.
So if I'm assuming that this is A and B, right, I'm going to be using this. So in order for me to find the direction, I'm looking for the angle, right?
I have a question.
Yeah.
What is A and B?
A and B is this, is the numbers in the
But, like,
component.
on the triangle, what is it?
It's this and this. This is A, B. Yeah. Okay, so on this one, my A is what?
A is 2.
And 9 is?
Wait, what? Oh, like you said.
So I have tan of theta equals B over A. So 9 over 2,
Yeah.
right?
Yeah.
And if I want to find theta, because my direction is the degree, if I want to find theta, what do I do?
First time.
Tan negative 1
Yeah.
of each side.
Is that the correct
So
way to
this
say
cancels
it?
out.
Inverse
sine.
tan, technically.
No, it's like,
Okay.
Inverse.
no, yeah, it's tan negative 1. Because there's also a cotangent and a
Yeah, that's different.
secant, yeah.
No, I was talking
It is
about like
different.
reverse sine.
Okay, tan negative 1, 9 over 2. What is it?
77.47, 77.5.
Yay. Wait, how did we understand that that's what they were asking for though?
Huh?
How do we know that that's what we're supposed to do?
Because it's looking for direction. So direction is the degree.
Where's he going?
Oh,
The
so we're just talking about
direction
the
is
sine
degree.
angle?
If they
Oh, I
ask you
see.
for magnitude, then you know you're looking
All
for,
of the 0 degree sine.
Right.
Okay.
and if they're asking you for component, then you know you're looking for that.
Makes sense.
Okay, so this one is written the same way, except I is one direction and J is, it's just similar without having to write this. But our A is what? Negative 7, and our B is 2. But it's the same thing. We do tan theta equals 2 over negative 7.
Oh, you just ignore the
I and the J.
These,
Under the
this is
variable?
another way to write it, right? And so it's, I could write it like this, negative 7 comma 2.
That's strange.
Or I can write this as 2I plus 9J.
Wait, why didn't you use that formula right there that says magnitude sine theta?
This,
Yeah.
I could use that if I wanted to,
However-
right? I would then, in order for you to use this, this is telling me,
No, not the blue one, the pink thing below it. that
This?
says- Yeah.
it's the same thing. V sine theta is this one in front of the I, or the first number, or A, right? And then V, magnitude cos theta is A, magnitude sine theta is B. So I could do that with here, but then I'd have to find the magnitude of this, and then sine theta, and then I'd have 3 thetas that I'm looking for. But it's the same thing as saying B and A. It just matters in what information they give you. And they're giving you options with all of this. Yeah.
Okay.
Would we flip the 2 over negative 7? Because we did 9 over 2. We did B over A.
This is B over A, 2 over negative 7.
Oh, okay. Wait. Oh.
So this cancels out. Look at me. Theta, what? Tan negative 1. What's tan negative 1 of negative 2 over 7?
negative 16. Oh, it's 15.9.
It takes,
Power.
I don't remember.
Anything that you gotta,
it's the amount
effort.
of magnitude. I wrote it down. I wrote it down in normal people talk. No. No. It's the magnitude of force applied to an object
Alright, that's. Make it move.
multiplied by the distance through which the object moves.
Thank you, Speed.
Good day.
Multiplied by the distance through which the object moves parallel.
Bless your heart. Bless your heart
To
too.
apply force. Moves parallel to the. So what's an example of force?
A force or?
So dot product is a way to find the magnitude applied, the work using vectors. So dot product, you find work, but because there's different ways to find work, right? In physics, you have a formula, but in this case, you find work using vectors, using vector operations. So we have to start with the basics, and the basics is this, the dot product of a vector. So you have two vectors, each vector's direction, A1 and A2, B1 and B2. This is called the dot product. There's literally a dot. So you're not multiplying them, but in a way you are. The dot product is you take the A1 and B1 and multiply them together, and then you add an A2 and B2 and multiply them together. So your dot product's answer is not a vector, it's a scalar. So you'll have a number, a singular number that describes the dot product. Yes? You with me?
Yeah.
And when you have a dot, and then when you multiply your dot product, and you end up getting a 0, this means that they're perpendicular. Right? Which is basically the same thing as orthogonal.
Which is the same thing as what?
Orthogonal.
Orthogonal. Oh. But there's still work done, even though it's perpendicular, or what? Or what? Orthogonal just means it adds up to 90.
Orthogonal means they're
Yeah.
perpendicular
Yeah.
vectors,
Okay.
right?
Yeah.
But the work is still, yeah, it's the same. It just identifies something about the vectors.
Wait, so perpendicular vectors, the what?
If you find the dot product, right, if you do all of this to your two vectors that you're dealing with, and you end up getting a 0, that just means that the vectors are perpendicular. They cancel each other out. You with me?
Wait, they cancel each other out, or they?
Right, so the one force then cancels out the exact force of the other, making you end up either in the 0 product. I mean, at the 0.
Okay.
Because if you take one and you apply it to the other, and the force, it cancels each other out, then you end up with a 0, 0.
Yeah, that would be if they're going opposite directions, right? Not as a 90. Or does it cancel out to be 0 at a 90?
When the tails or the heads touch, they both hit at a 90.
Okay.
Either or, not both. Either or, it hits at a 90. Not all your vectors are going to be orthogonal or perpendicular. It's only that if it equals 0, then it is. So they want you to find u dot v.
Oh, okay, that's what I'm trying to.
So then you would do what? Negative 3 times
3.
4.
3
Oh.
plus 4
4
times
6.
6, which is
15.
negative,
Oh, what?
Negative 9.
9 plus 24.
24.
which is,
15.
Streak. I don't know.
so then we have, so then this is, the dot
That's
product
UV.
is 15, so this is orthogonal.
No. Wait, so how, that was A1 times,
This is U1, U2, B1, B2.
yeah.
So then it's A1, B1. So the ones get multiplied, and then the twos get multiplied, and then you add them.
Oh, I was thinking it was A, B. A1 and then negative 3 is A and then.
No, they put it up here. A1, A2, B1, B2, because they're not points.
Missy,
Yeah,
how do you know it's not orthogonal?
because it's not equal to 0.
If it's
Only
equal-
when it's 0.
Only when
Yeah.
it's due to this or okay.
All right, so to find an angle between two vectors, which you had a lot of story problems last section on on finding the angle and the missing magnitude, this is a way for us to use dot product to find the missing degree. So you have the two vectors, A and B, and then theta is what we're missing, so you do cos of theta, so we're solving for theta, and then the dot product of A and B, and then the magnitude of A and magnitude of B. Who remembers how to do the magnitude of A and magnitude of
You
B
just
from A to
time them each other.
Square root
Oh.
A
Oh,
squared
yeah.
plus B squared.
Right, so the magnitude of A would be
Square.
A squared plus B squared square root.
Same as
And would this magnitude of B be the same thing?
yeah.
Huh? Yes. Right? So here is, this is confusing because this is
Because
A.
this is
We
different.
can do A1, A2 squared. That makes more sense. The two parts of the vectors, right? So this would be cos of theta equals the dot product of AB. Maybe we should find the dot product of AB first, or in this case, it's UV. So we're going to find the dot product of U times V, which is what? 1 times
2,
plus,
negative 4 times 6,
which is
2 plus
2
2 minus 24,
minus 24, which is,
negative 22.
and then we should find the magnitude of A, which is square root of, magnitude of U, which is the square root of, 1 squared plus
1 squared plus 2 squared.
negative 4 squared.
Wait, I thought you said you were gonna do A1 and A2.
Right, this would be, it's the same in the vector. This is U1, U2. This is V1, V2. Remember? It's the same. So if I find the magnitude,
So it's both A's?
if I'm finding the magnitude of a vector, I'm using the two values they put in there,
Alright.
right? So then we have the square root of 1 plus 16, which is the square root of 17,
Oh, never mind.
right?
Then
And then
you
the
have
magnitude of V, for now, I'm just gonna leave it in the square root. The magnitude of V is the square root of
2 and 6.
2 squared plus 6 squared, which is the square root of 43640. Yes? So let's put it all together.
And do you multiply them? Is that what?
Yeah.
You do? Okay.
Cos of theta equals the dot product, so negative 22 over root 17 times root 40. So find this in
40.
decimal.
40.
Sorry.
Move.
Put this all in decimal. Put in your calculator, what do we get? 26? Wait, what? It's all, it's, the bottom is 26 or the
Yeah,
whole thing is
the bottom
26? Okay, so then find negative 22 over 26.
Negative 0.84? I don't know, let me check, because this is a really.
Is that what everyone got?
No, let me check.
Yeah, it's like negative 0.84.
Okay, so then how do I solve for theta?
Reverse cosine, so cosine inverse.
Cos negative 1 and cos negative 1.
So
These cancel out. I end up with
147.5.
theta equals what?
147.5. Or do I have it in degree? I do.
Projection, okay, we're gonna have some problems on these, but the point of the vector projection is when you're connecting two vectors, heads and tails, and they end up being parallel, right? So if I have a U, now we can take this and take this and put it into here, right? And then solve for that. But this method is asking you to take U and put it down so that they are parallel to each other and they meet that way. So I'm taking U and I'm doing, it's called the projection of U. It's the projection of U onto V.
Are we assuming that it's gonna, are we transposing it? Like transferring the whole thing down, or are we just pivoting it?
You're
'Cause that's
transferring
what
the
it
whole
looks
thing
like.
down.
Okay.
Yeah. No.
It's not like it's just a trans,
You're
it's a
taking it
translation.
and
Okay.
you're just, yeah, putting it down. So sorry, these are actually supposed to meet, is what.
Oh my gosh.
Wait. Okay, so it is just pivoting then.
Sure.
Okay, that's what I thought. It's like,
Okay, and
Okay.
in order to find that, in order to find U, when I have this, the projection view of U is called W1, right? And W2 is, it's supposed to be,
Oh,
Is that a
no,
straight
the
line?
triangle.
Yeah.
Supposed to be.
oh, good.
so
Okay.
this is at a perpendicular angle, at a right angle, this is W2. So U is the value of W1, the projection of V, U onto V, plus W2.
Hold up, what's that?
Wait, is that bottom line W1? Or why did you say W1 equals
Times projected
What?
V.
This is W1 equals the projection of V. The projection of U onto V. So sub V U.
And they equal
And
zero.
that's the value of W1.
And W1 is that?
Is this
Line?
one. This is W2.
So
So this is W1,
Oh.
this is W2, and adding the two gives you vector U.
Yeah.
Or vector U gives you these two.
Okay, so that one's not the same as that one. The
Yes.
orange one is not the same as U black.
No.
That's what I was thinking. I was like,
Because
how
the
can
direction
this
is
be that?
different, so the work is, you know,
wait,
if
Well,
you're
this is the
shifting.
Pythagorean theorem. You can't be the hypotenuse can't be the same size as the leg
No.
anyway.
No, but if you're thinking about it, if you're shifting and there's another force coming, right? Then taking a vector and just shifting it wherever you like is not going to, it's not going to be equal value. So in order to find the correct value, you W1, W2,
So
that gives me U. Or I took U and I split into W1 and W2, this is my project, then I project U onto V.
But we
Now,
still have to assume that U ends at the same x, on the same x coordinate plane
Right.
as V starts.
yes, this is assuming that U is then parallel to V.
Once it, wait, what?
wait,
This is
so
making U,
confused.
this is making the slope of U parallel to V. That's why you have to do the orange. By doing the orange, I've then taken vector U and made it parallel to V, right? Combination. So then I just add the two to get me U.
Yes.
And again, these applications will come in handy when we do story problems.
That's interesting.
Yeah,
What's the?
this is a strategy to a solution, huh?
What's projected V, whatever?
This one, this,
Yeah.
right? I'm taking U and I want to project it at an angle that V and U are now parallel, and they make a straight line.
So should
Right?
you see that
So
little
if I
equation
do
down there?
this work, if I do the orange work, huh?
That's not, this
Scroll
is
down, it's a lot.
not parallel or
They're
the
parallel
same?
because they have the same slope.
Okay.
They are, I have to first make it parallel,
Oh, yeah.
and then because I can attach, when I attach these vectors
Are
this
they the same
way,
length?
when I attach this vector, they don't have to be the same length, no. And when I attach this vector into here, right, I have to keep the direction. So in order for me to do the direction to change it, I have to then, it's called projection.
So
The
what you,
projection of u onto v. And that's where this comes in handy. Right
by
now, it's
what
not the time.
rules? Okay. I
Right now, it's
understand.
not the time for you to figure out the application. I just
I know,
need you
I'm not
to,
thinking
I
of
just need you
application.
to identify the different parts, and once we identify the different parts and able to find this, then you can see where the application will fall.
Sure.
I'm still confused. Why is W equal to that one formula that's down there? Why does it say projecting whatever?
This is W1,
Yeah, but why does it say equal to
Yeah.
projection? And then it says
because
down
it
there
is,
that.
because your
So then
W1,
W1
because we
equals
took
that
U,
formula?
we
Then-
took U and we split it into W1 and
So
W2.
then W1 equals that formula.
Yes.
Okay, thank you. Really, graduation?
Is that helpful?
Yes.
Then if you have W1,
Okay, so how
you
can
don't need
you
to do all that,
change?
right?
What?
If you already have W1,
Right.
then you don't need all the,
Right.
then.
But that's only if you have W1, but you don't have W2. I mean, if you have only W1 but not W2 and not U, you won't be able to find it. It just matters on what information they give you. Because you will need this. If you don't have U, you're going to need this to find U.
But if you only have one of those, do you think you can find the rest of them?
It's possible, it just matters, again, it matters on what information they give you, which is what you're talking about, and what you're looking for.
Okay, so
If you have a W1 and they're asking you for what U is, then you need a W2 and you need to find a way to find it. They're not just going to give you one value.
is there like a specific like way that you can change the direction of the vector and still have it the same vector? Well, how can you?
But we're
change
not
it?
just changing the direction of the vector, we're purposely changing the direction of the vector to match the slope of V. So it's not just like I'm going to move it this many degrees. It's I need the slope to match V, so I have to connect U and V. This formula allows me to make U and project it so U and V are now a straight line.
What?
It's not just moving it.
I guess.
So we change the magnitude of.
No, you're not changing the magnitude at all. You're connecting the two magnitudes and changing the direction.
You're changing the direction of what?
Of U to be parallel to V.
How does that follow the rules?
Because
of
if I
math?
took this and I wanted to put it on, it would look like this.
Yeah.
But I want to find a way to then match V.
Is there an inherent rule in math that allows us to do this? That you can
Yes, there's
explain
an
to me
entire
right
proof
now?
on how they got that formula. You can look that up. There's an entire proof on how, mathematical proof on how they got that formula.
Oh,
Yeah.
that's enough for me. I just want to know that it
Is it
exists.
time to go? What time is it?
150.
Oh well. See
Okay,
you tomorrow.
I want you to solve number 3.
Right now.
Oh, just shut. Oh my God. Okay, I'm gonna leave that on there. Please do. I'm gonna leave it on there.
That's another.
Future reference, Miss
So this is what I gave you yesterday. Projection
What page is it?
U onto V, 503, equals.
Look at me now. Go with Jonathan.
U dot V over squared equals. Oh,
Not equals
times
close
V.
and
Look
V.
me in the eye and say it slowly.
Okay, so U dot V, we'll find that first. So let's find the different parts. So U dot V
26.
is U1 times V1 and then U
26.
squared.
I already did it.
I know.
She's doing it for the video.
This is in case you get stuck because you forgot and then now you're going to see me on camera after Anya does a scan.
It's 26 though.
So it's 4 times, you guys are going to be the death of me.
Nah,
Yeah,
it'll be the
Nico.
next class.
Yeah,
It's
Nico.
gonna, yeah, that class is rough.
You have to deal with the rest of the juniors.
Okay, so next class?
I didn't
Oh,
mean the
I
8th
meant my
grade.
next period.
No, no.
I was talking about the middle school.
I'm sure middle school is
Negative
bad
4 plus 30 is, what do you know it, 26.
too. Thank you, Amadou.
Okay, and then let's find this right here. Squared equals, V is square root of, stop whispering, Noel.
That's Nico.
They're flirting. Nobody
Yeah.
help
That's
me.
Nico.
B and I are hearing it all.
Beatrice is done. These actually cancel out. So we're
So
doing
wait.
4 squared plus 6 squared equals 16 plus 36, which is 16 plus 36.
No, 52.
52, LOL.
Thank you, B.
I don't math.
Okay, let's put it all together. That was mine. A, B, C. Okay. So we end up with 26. This is 26 over 52, and I times it by V, which is 4 comma 6. So what is 26 over 52?
As a decimal?
No, what is it? Reduced fraction.
1/2.
Half.
One,
Instead
oh.
of
So it's 4 over 2, comma 6 over 2, which is?
Oh.
2 and 3.
Right, because this is 1/2, 4 comma 6. Guys, what's Paolo? This is 1/2, right? It reduces to 1/2, and then we distribute it to each one. So then it becomes, so it's 3,
2 and 3.
2, comma 3. This is then W1.
That's 1/2 of what we need, isn't it? Or
This
is
is
that-
W1?
Yes.
Are you
So we
serious?
already have, calm down. We know that U equals W1 plus W2, right?
Damn, we just did one.
Wait, shh. Now I have to cut that out. I know that U is -1 comma 5. And we know that W1 is what?
2, 3.
2 comma 3. And then W2 is X comma Y, something comma something. So actually, yeah. So I know that I do 2, if it's 2 plus X, -1 equals 2 plus X. And then 5 equals
Wouldn't that be?
3 plus Y. Are there any questions on how I set this up? I know that these two added together has to equal this, and these two added together has to equal this. So then
Now just a system of
I
equations.
subtract. No, it's not, because because I'm looking for individuals.
Oh, okay.
So then this is -3 equals X, and this is
2 equals
2
Y.
equals Y. So my W2 equals -3 comma 2.
I can't see.
Wait, you couldn't, why didn't you just, you have to write it, you have to write it out like that, you can't just subtract.
You can't, I just wanted you to. You can do it in your head. I mean, you guys can technically do this in your head, you don't have to write that out, but I just wanted you to see where it came from. So then our second answer is to put U equals W1, which is 2 comma 3, plus W2, which is -3 comma 2.
And that's
And you don't solve it, you
whole.
don't leave
Yeah,
it like
it is
that?
the whole.
No, because it's asking to find the projection of U, so we found it, and then write U as the sum of vectors, and these are the sum of vectors.
Oh, okay.
And they want you to write it in that. So we're dealing with vectors in 3D space. 3D graphing just deals with a third axis. So we have our X and our Y, which kind of goes two-dimensional, like on the floor, you have your x and your y, right? And if you think of like a corner where you have a line that goes straight through as a third dimension, that would be where this comes from. So here, and it would be a right angle to y and z, x and y is our z. Okay? So our 3D coordinate system is an x, y, and z. Your distance formula and your midpoint formula deals with just these. And it deals with these in 2 dimensions. So this might look familiar, right? Between 2 points, and then it's between 2 points. So the third one just feeds off of the equations you already know. Yes? So this should be a piece of cake. You're just filling in. And for number 1, they want us to just point the plots. So x is first, then y, then z. So you're going to go out on x, and you're going to go 1. Then on y, you're going to go 1, 2, 3, 4, 5. And then on x, z, you're going to go 1, 2, 3.
Holy cow.
So this would be 1, 5, 3. 2 would be the same thing. We're going to start on x, back 1, down 5, and then we're going to go up 2. 1, 2. And this would be -1, -5, 2.
Wait a second. What if you wanted to plot, like that same one, but you wanted to plot like -2 on the x-axis and then negative like.
So -2.
Yeah, and then go down 3.
1, 2, 3.
And then go up all the way to like +5. That would look like the same line.
1, 2, 3, 4, 5.
No. On the y, you wouldn't go. It'd be at 0, 0 z. It would look like the same line. I'm just saying, like, if it was on 0 z.
Right, because you're trying to draw a 3-dimensional point on a 2-dimensional surface. Oh, actually, 1-dimensional surface. So yeah, it would slightly be different. One might be over the other, but if you did it on a computer, you'd be able to shift your perspective to see that there's a depth difference. Yeah.
Can you do the 153 again?
Oh, yeah. Really? Wait, where?
We do 1,
These children smell like onions.
5,
Lucas.
3. So just write that down.
What?
Yeah,
Wait, because it looks like you're going on Z.
Yeah,
start with X.
This is the only
You
distraction.
start with X, 1, then up on
But it's
Y,
not going down.
1, 2, 3, 4, 5.
Oh, no, wait.
And then you go up 3. 1. So if you think the 0, 0 starts where you're at, because you're going to shift the point, you go up 1, 2, 3. It's going to be an adjustment for sure, because it's 3-dimensional, and you're drawing on a 2-dimensional. So write this down and try to find the distance.
Wait, but where's the 3 on the Z?
The 3 is here. You go from here 1, 2, 3.
Leonie, what happened to your wrist?
Just do the distance formula. It's gonna
Because that graph, where's the 5 at?
It's going different direction.
It looks like you go down to the 2 on the Z.
well, you just imagine it taking one axis at a time. So just ignore all the axes, just focus on X.
Okay,
And then you
so-
focus on X and then Y.
Wait.
And then you focus on Y and then you go, and it's like you're pulling it up.
Where's the -x?
So this is, if I drew this, negative X is this way. Because I've taken this,
Then how come for your negative
I've taken
x,
this and I've put it here. You see
how
the
come
shift?
it lines up with like the 4 on x instead of the 1?
What? No, the 1 is still here. It's still here 1.
Talking about the second one.
The second one is 5. So 1, 1, 2, 3, 4, 5. And then it's like pulling it out 3.
Where's your 1 though? That's what I'm having a hard time with. Because it's not lined up with 1. It's lined up with like 4.
For X,
Yes.
it's 1 right here. It's at an angle. It's going straight there. 1, 5, and 3.
It's not a perfect drawing,
Did we find a distance?
I got 10.24.
What is it?
10.24.
10.24. Anyone else get something different? That's what we have?
10.25.
Okay. Huh?
Yes, we rounded.
Smack him. 25.
B, that's not nice.
Oh well.
Really hard.
Okay. Find the component form and magnitude of AB with A 3, -2, -1, and B 1, 5, -3. And then find the unit vector. So the magnitude, so we got to find the vector component. It's the same thing as two-dimensional. The vector of AB, we take the first number, the second number and subtract it. So 1 minus 3 is?
-2.
-2. 5 minus -2 is 7. And then -3 minus -1 is -3 plus 1, which is?
-2.
So this is my vector component, right? The magnitude.
We all finished our test.
I have my license.
I'll give it video effects.
Zooming in.
Want the keys?
See? It was recorded. U times V, which is I, J, K. And the first one is -3, -4, 2. And this one is 5, -4, -1. Okay. So from here, we've done matrices before. When you do this one, the triple scalar, you can put that in your calculator. But this one, because we have these values, I'm not sure if if the calculator will understand what you want it to do. So basically, we're going to take I and then find the determinant of this corner right here, -4, 2, 4, -1. So whatever letter, I take out that row and that, and the determinant is the 4 left over. You understand? So the next one is J, and J is here. So the 4 left over is -3, 5, 2, and -1.
That's weird.
Well, that is what we're
So
doing.
this is just something we have to memorize.
Did you memorize how to do
This
that?
is what we, no, this is what we did.
I know, but did you memorize like how to do that?
Yeah, and then yeah, that's how I memorized how to do it. But you can have a cheat sheet on the test. It's not, they have it written out there. It's just I don't like to match letters. I make more mistakes that way, so that's why I'm telling you this, but you don't have to memorize it. You just have to be able to write it down. So K is -3, 5, -4, -4.
So is it always gonna be the I first and then negative?
Yeah.
And then, okay, so it's gonna be all.
And so it's going to be positive, negative, positive. Right. And then from here we find the determinant. So -4 times -1 is +4 minus -8 I minus 3 times 10 J plus 12 times -20 K. And 4 plus 8 is
Wait, did we do that? Oh, yeah, we did.
12I minus 30J minus,
Wait.
Plus.
Are you certain? Is it -3 minus 10?
ooh, you're right. Oh, it's been a day, guys.
How come it goes minus positive, minus and then plus right there?
Because that's how it is. It's positive, negative, positive. It's over there if you see it. That's how it's written on the equation.
Can you stop putting those tails on the eyes?
No. Okay, so -3 minus 10 is -13J, and then 12 minus, this is -20. So 12 plus 20 is
32.
positive 32
Oh, we beat them all.
KK.
I'm still writing it down.
So then the area is the magnitude of U and the cross product of U and V. So then I take this and I do 12 squared plus negative 13 squared plus 32 squared, which is 144 plus 1, what's 13 squared?
169.
And what's 32 squared?
1024.
And then 141 plus 169 plus 1024. Is Noel the only one with a calculator?
I think I am.
And then in decimal?
Noel's the only one with a calculator, wasn't Noel?
It's a 36.5, Misty.